I want to make a video about curvature. I feel that I kind of squeezed this into the end of one class here. And so I just want to show just one nice thoroughly worked through example with some explanation here. So for curvature, what's the definition of curvature? It's a measure of how much a curve changes direction. And so if we have something like this here for our curve, this isn't really changing direction very much. It's changed direction some, but not too much, especially if we compare it to something like this. Our measure of curvature needs to say that this curvature is smaller than this curvature. This one's changing in direction a lot more. And so kappa is our Greek letter that we're using to represent the curvature of a function. And we have an R of t that traces out, each of these curves here. The only formula I want you to be familiar with is this formula right here. The magnitude of r prime of t cross r double prime of t, all of that divided by the magnitude of r prime of t cubed. If you want to see like a derivation of this, check the textbook. I'm not going to work through it. And this isn't something I expect you have memorized, but it's something you might want to apply at some point. So let's crunch this out just in one particular example here. Find the curvature of a circle of radius r in the xy plane. So here is a circle of radius r in the xy plane. We want to parameterize this with an r of t and then apply our curvature formula and see what happens. So r of t is going to be, we can parameterize with big R cosine t, big R sine t, and 0. This is in the xy plane when z is equal to 0. Of course, t runs from 0 to 2 pi. Okay, what do we need here? R prime of t, R double prime of t, their cross product, and some magnitudes. So let's start getting these crunched out here. R prime of t is negative r sine t, r cosine t, and 0. R double prime of t is going to be negative r cosine t, negative r sine t, and 0. Their cross product here, I hat j hat k hat, negative r sine t, negative r cosine t, and 0, negative r cosine t, negative r sine t, and 0. And when we calculate out the cross product here, the I hat component will be 0 minus 0. The j hat component will be 0 minus 0. And the k hat component will be this times this. That's r squared. There shouldn't be a minus sign there. That's a plus sign right there. That hasn't changed any of my answers so far here. But this times this gives us r squared sine squared t. Minus this times this, minus times minus is plus r squared cosine squared t. I think we can see that this simplifies down to 0, 0, and r squared. So then what's the magnitude here? What's the magnitude of this here? Well, it's just r squared. Okay, so we've got the numerator here of our kappa of t. Now we just need to say, the magnitude of r prime of t is going to be square root of negative r sine t squared plus r cosine t squared. So r squared sine squared t plus r squared cosine squared t. And that's just r squared. The square root of r squared is r. So our kappa of t is going to be, the numerator is r squared. The denominator is going to be r cubed. And so our answer here is 1 over r. So this should make sense. This should make sense in a qualitative way. Why is that? Well, let me draw a circle of radius. Let's just say this is radius 1 here, and a circle of radius 3. So here's a circle of radius 1. Here's a circle of radius 3. The kappa here is 1 over 1 is 1. The kappa here, the curvature, is 1/3. And I think we can agree that you are changing direction a lot more in the circle of radius 1 than you are in the circle of radius 3. You're changing direction a lot more gently. So this kind of checks out.